Welcome to another ZBD developer tutorial. In this tutorial, we'll attempt to retrieve the player's device information, save it to Beamable, and use it to adjust reward values and display warnings to the player. So in this video, we will cover two parts. In part 1, we will try to get the player's country and device information such as country code, locale, device name, time zone, and IP address from the client side and saving them to Beamable. Additionally, we'll use the ZBD API supported region endpoint to verify if the player can access ZBD services before enabling it. In part 2, we are going to utilize these data to send different reward values to the player and check if the player tries to alter or change any of the device or country information, then send alerts based on that. Now, let's delve deeper and begin with section 1. In this section, we will gather specific information about the player's country and device from the client side using different methods. Also, we will obtain the country code from the Beamable dashboard under the status section and save our player data accordingly. Just like in the previous video, it's important to ensure that you have added Beamable and ZBD template to your Unity project and that Docker is running to run and test the microservice. After that, you can utilize the existing script called rewards controller or create a new one. For this case, I have created a new script called game manager and attached it to an empty game object named manager. Now, let's start by obtaining the device name. Inside the game manager script, we have this method called getUserDeviceName to get the player's device name and display it in a text element. To get the country code, locale, and time zone, we will employ different methods. The first method involves utilizing the player's device GPS. Firstly, we ensure to add the necessary permission to the Android manifest. Then, we call the startGPS method within the awake method. This code ensures that the required permissions are granted and that the location service is activated before initiating GPS functionality within your game. It also handles potential errors related to permission timeouts and disabled location service. Next, we call the getCountryCode from GPS method within the start method. This method verifies the permissions and the state of the location service, then retrieve the device location data, latitude and longitude if available. The objective of this method is to get the latitude and longitude, which are then used as a parameters in the query country code method. This method makes a post request to an endpoint to obtain the country code and name based on the provided latitude and longitude. Additionally, using these same data, we can retrieve the time zone of the specific country through a separated method. Essentially, this involves another post request to a different endpoint to retrieve the time zone. Keep in mind that the endpoints we are using are free but may have daily limits, so you can explore other endpoints or methods to get the player's country code and time zone using their device GPS. Moving on, the second method involves making a post request to this URL to fetch information about the player country. We will call this method inside the start method, which then call this method. Within it, we make a post request to the motioned endpoint, wait for the operation to complete, and check if the request was successful. If successful, we retrieve the JSON response, deserialize it into an object, and extract the country code, time zone, locale, and API address to display them in a text element. Note that this endpoint is free but may have a daily limit of requests. You can use different endpoints or Google Cloud Service like the geocoding API and Reserve Geocoding API. Additionally, when a user uses a VPN, the IP address seen by this API will be that of the VPN server, potentially affecting the retrieved information. The third method involves getting information directly from the device using the locale and time zone libraries. In this case, we simply call the getCountryCode from device method to retrieve the country code based on the device current culture and region settings and display it in a text element. It's important to note that in this method, the country code is determined by the device's current culture and region, allowing the player to change it in their device settings. Regarding the time zone, we call the getTimeZone from device method to retrieve the local time zone of the device and display it in a text element. Now, Let's explain how to retrieve the country code from beamable stats. Firstly, we call the getBeamableGamerTag method to obtain the player's gamer tag. Then, we invoke the requestPlayerStats from server method, which takes the beamable gamer tag as parameter. Within this method, we interact with the gamer server microservice, specifically the getPlayerStats method. Inside the getPlayerStats method, this line is responsible for loading the game and private stats data within the microservice using location as a key. In this case, we are going to retrieve the country code. You can find this key in Beamable by navigating to the Engage section, click on Players, then select your player gamer tag, and then click on Stats. Copy the stats key, which in this case is location. Then, we return to the request player stat from server and display the country code from Beamable to text element. As you can see, we managed to get the player device and country information from both the client side and our server and display it in the game view. Now, let's discuss saving these data to Beamable stats. In the start method within the game manager script, we invoke the save data to Beamable stats method after a specific amount of time. Inside this method, we first check if the player has already saved the data the first time they launched the game using the canSave. Within the canSave method, we call canSaveData with the gamer server microservice and send the gamer tag as parameter with it. Then, we fetch for the player data save currency from the inventory service. We check if the player data save variable is equal to 1. If it does, it logs a message indicating that the data is already saved and returns false, indicating that data cannot be saved again. If not, we set the player data saved variable inside the inventory to 1 and return true, indicating that the data has been successfully saved. Next, we return to the save data to Beamable stats method and call the save stat method, sending the stats key and value as parameters. For example, we save the country code obtained from GPS using GPS country code as a key and the data of the country code as a value. You can save any data you fetch from the device. For example, in this case, we save the country code, time zone, locale, IP address, and the device name. Inside the save stat method, we create a dictionary named stat, containing the stat key and value passed as parameters. Then, we call the setStats method, which takes two parameters, the access, which can be public or private, and the actual value of the dictionary parameter stat that we created. Note that you can refer to the Beamable documentation to learn more about saving and retrieving stats with different access levels. In our case, we save it as private stats. Also, navigate to the Beamable toolbox within Unity, click on Content, and ensure to create a new currency named Player Data Save It. Then click on Publish. Now, let's explain how to use the ZBD endpoint to check if the player's region is supported or no. First, navigate to the ZBD documentation website and click on API reference. Scroll down and click on Supported Regions. You will find multiple examples of how to use this endpoint in various programming languages. You can directly test it on the website by adding your API key from your ZBD dashboard to the header and entering the IP address you want to test it in the path. Click Send and you will receive the response data indicating if the region is supported or no. Now, let's implement the same process in our game. In our game manager script, after obtaining the IP address, we call the detect support region from ZBD method and send the IP address as parameter. Inside this method, we call the isSupportedRegion method in our game server microservice. Inside the isSupportedRegion method, we typically retrieve the API key from the Beamable configuration. Then, we call the getAPIRegionResponse method and send the IP address and API key as parameters. Inside this method, we make a post request to the ZBD supported region endpoint and return the result indicating if the region is supported or not. Based on this result, within our detect support region from ZBD method in the game manager, if the region is supported, we enable the ZBD rewards prefab, otherwise we disable it. One last thing, don't forget to adjust the code inside the reward controller script and change this permission to the start method to avoid any null reference errors. Now, let's move to the part 2 of the video. In this section, we are going to first utilize these data to send different reward value for the players and check if the player tries to alter or change any of their device or country information. Then, send alerts based on that. Let's start with adjusting the reward amounts. In our game, we offer time-based rewards where all players receive the same amount of sats. However, we plan to customize this based on the player country code, as different countries may generate varying ad revenue. For instance, we may consider sending a larger amount of sats to the player based in the USA, while sending a less amount of the players in other countries. First, navigate to the Beamable and select Config. Click on Add Config and in the namespace, add Countries Code Reward. Then add US and TN as keys, along with the desired reward amounts for each country. For example, let's set the value for TN to 20 and US to 50. Feel free to adjust the country code and reward amount as needed. Click on Add to save the configurations. Now, let's delve into the code and see how to implement this. Inside the sendPlayTime method, add a new parameter called user_id. Then we call the method called getPlayerCountryCode and pass the user ID as a parameter. Within this method, we retrieve and return the player's country code. Once the operation is completed, the country code is assigned to a variable called playerCountryCode. We then check if the player country code variable is not null or empty. Depending on the country code, we adjust the reward amounts accordingly. Note that instead of using Beamable country code saved inside the stats, you can use the country code fetched directly from the device, using one of the methods discussed in part 1 of the video. Now we have successfully adjusted the reward amount based on the player's country code. Let's discuss the final step in our video, sending a warning to the player if they try to hide or change their country information. As discussed earlier, we managed to obtain the country code using the device GPS, a post request to the endpoint, the device locale, and finally from the Beamable stats. However, players may attempt to hide or alter this information using methods such as VPN or changing device locale settings. To address this, we create a method inside the game server called checking country code. Within this method, we attempt to retrieve the saved country code from Beamable stats and compare it with the one obtained from the device. If they differ, we show a warning to the player indicating that the country codes do not match. Similarly, we perform a similar comparison for the time zone. If the time zone values retrieved from Beamable and the device do not match, we display the same warning panel with a message indicating the mismatch. In both cases, we create two methods called checkCountryCode and checkTimeZone, which are invoked after specific time intervals to continuously check the country code and time zone information. Within these methods, we call the responsible method inside the microservice, and based on the result, we decide whether to show the warning panel or not. Additionally, based on this information, as discussed in the previous videos, you may choose to add the player to a blacklist or whitelist. This because a player may initially use the game in one country with their device and control information saved in Beamable, but later change their location, resulting in mismatched the country code or time zone. It's important to note that these solutions do not guarantee 100% prevention of the player hiding or changing their device and country informations. However, they serve a way to reduce such actions and make them less common. Now, let's build the game and test it. As you can see, we successfully retrieved device and country information from the both client and server sites. Additionally, the ZBD rewards prefab is enabled since ZBD supports my region. Furthermore, my device and country information have been successfully saved to Beamable stats, and I received 50 as the reward amount because my country code is US. Now, As you can see, I received a warning panel indicating that the country code does not match. Please contact support, because I'm using a VPN to change my country code to US, but the country code from the device GPS is TN. Now, if I disable the VPN and reinstall the game, you will notice that I received 20 as the reward amount because my country code is TN, and I didn't receive any warning panel indicating that the country code does not match. Note that displaying all this data in your game isn't necessary. The purpose here is to illustrate how we can retrieve such information from both the client and server sides and utilize it later in this tutorial. Thank you for watching. I hope you enjoyed this and found it useful.